Hi there, welcome back. Well, I've been looking at this Braun Regie 450S. I found schematics online. There were about 5 separately. I put them together in Photoshop so I can get one working model. And I think I can now sort of identify the parts. And as you can see, this guy is completely loose. And this is the board that had some of those tracks or some of the pads that seem to have been removed or damaged on the underside. This thing has definitely been played with. There was a shield that was floating around, and that shield looks suspiciously like something that would have come out of this, probably in here. But what I've decided to do now is I'm going to remove that board, and before I power anything up, the rest seems to have been left alone. I've also figured out what that burnt resistor is, so I should be able to make some progress. But I'll remove this board, and all it takes is you take off these antenna connectors. This is the FM antenna that comes into this part here. There's this guy, which just pops out of there. And then there's this big connector here, which just pops out of there. And we should, I think if I just desolder that, shift these a little bit, I'll be able to take that out. I've also got to desolder those 2 contact points from the chassis ground on the underside. Can't see much on the top side except for a crack. Part of the board is cracked over here. Definitely a crack there. What has that done to the underside? Oh, crapper. The board is cracked here and it's gone. The cracks go through some of the traces, PCB traces, on at least 2 points over there and over there, which means those traces are probably broken. This thing is just floating around somewhere. The parts where the traces seem to have disappeared are over on this end. There's something that's been removed from there and not replaced. What was that? There's definitely something removed from there. Some of these pads seem to be gone. That one's been lifted. There's another one. But I'm not sure there's anything underneath there. We'll have to see. But yeah, this thing's definitely been played with. This thing's been removed. Okay. FM front end. Oh God, I pray nobody's messed with this. Doesn't look like it. This looks complete. This thing has been bent. This thing just fits nicely in there and in. So I'm just going to put it in gently for now. And I'll tell you what my idea is. I'm putting this aside for now. And this is what I'm going to do. Now, I know that parts of the radio are still in here. Section are still in here, but most of the radio is on that board that I've just removed. The reason I say parts of the radio section are still in here is because that thing that we saw over there that I couldn't quite identify, that is indeed a tuning capacitor. I've seen the dial cord go across and it turns it when I turn the tuning. There's a preset tuning board up front here, which obviously is part of the radio. There probably are a few other things like, well, the actual band selection is down at the bottom here, so that goes to, it's probably on this connector over here. But this is my idea. Remove everything to do with radio, and what are we left with? We're left with signal processing, preamplification, and amplification, and obviously the power supply. So this is what I want to do. I want to treat this thing like I do tube radios, which is check the power supply. Once the power supply has been confirmed to be working, go to the power amplifier or the preamplifier and amplifier. Now obviously this thing's got a lot more on the preamplification stage than the tube radios does, but it's still the same concept. You have power supply, power amplifier, before that is the preamplifier, and before that is all the radio. Okay, makes sense. It actually ends up looking quite simple. So by removing this radio board where I know some damage has been done, I am fairly confident that I can now start testing this like I would the normal tube radio procedure, which is power it up under dim bulb, check to see if any signals going in from one of the audio inputs, one of the line inputs. Now we've got two here. We've got phono, which has probably got some other preamplification between it and a normal preamp. But we've also got tape in. Now tape in normally is line level. So that'll be the purest signal to try and trace through here. And the idea is inject a signal into the tape input, follow it through and see if it gets out of the power amplifier. If we can do that, or when we can get that done, we know the power amplification stage and the preamp stage is working. We might have to divide that into more sections, like test just the power amplifier, where the preamp goes in, and then go back and check the preamp. Or, if there's nothing on the power amplifier, we check if there's something coming out of the preamp, and then we know the problems with the power amplifier. And of course we've got left and right on everything here, so we could have one channel working and the other channel not working. So it makes the troubleshooting a little bit more interesting. And the reason I just didn't switch this on is because I knew something had been fiddled here, and you don't know what they've done to the power connections. You could have a direct short over there and do more damage. Now the damage I did show you on the board is actually quite obvious. There's a setup here which is a voltage regulator section which produces 25 volts, and then the 25 volts again has another subsection which produces 15 volts. And that resistor, or those two resistors in that transistor, are actually the pass transistors on the 25 volt line. So that tells me that because that transistor or that resistor is very charred, there's been excessive current draw through that. So something could be wrong with that voltage regulator. So that's one of the first things we have to check as well. And this is the little schematic. I've stitched it all together in Photoshop, so I've got one working schematic. I hate flipping from one page to the other. But to make this a little bit more obvious, I've got three colors on here already. You might be able to see it. I have reds, oranges, and yellows. Now what does this mean? Well, what I decided to do is to create or indicate the power supply lines more clearly. And what we have here really is one very simple power supply. You've got the transformer here with a switch and a fuse. The secondary goes through to here. It feeds actually it feeds three lamps in series with a current limiting resistor between them. But we'll ignore that for now. And then it goes to a bridge rectifier, one bridge rectifier. That bridge rectifier has these two smoothing caps, which were the two that I pointed out, those yellow ones, filtering, and you should get about 47 volts out of that. It then goes to the two power output stages. It feeds the left channel and the right channel. And then, of course, the other supply is ground, which I haven't indicated here. The same applies on this side. It feeds those transistors over there. But then it does something else. It carries on through here on this side only. And you've got a 160 milliamp fuse. And then you've got this little thing over here. And this is just a voltage regulator. And the resistor that we see that's been fried is R805, which is that guy over there. Now that resistor has the fuse protecting it, 160 milliamps. So it shouldn't have fried, but it's a 15 ohm resistor and it feeds this Darlington set of transistors. That one there being on that on the chassis, heat sinked to the chassis. And that other resistor, the big brown one, I believe is that guy over here. So we've got one very charged resistor here, One very brown, looks like it's cooked a bit. Over here, it's a pretty high power one as well. I'm just not sure if it's that particular one because I can't see the marking on it. And then what happens here is this thing supplies the pass transistor. This pass transistor is fed by this driver transistor. So you've got a Darlington pair. This point here is a reference voltage, which is created by these diodes. This is probably one of those sets of 4 that we've seen before. And a Zener 12 volt, it looks like. 12 plus, what is that? Well, you can adjust it here. I presume, yeah, you can adjust it here. This is a feedback section from the output, which should be 25 volts. So I presume you adjust it till you get 25 volts. It's using this reference and this transistor to give you the right drive to give you 25 volts at the top here. So this orange is the 25 volt supply line. And then it creates also from the 25 volt supply line through this resistive divider over here, 1, 2, 3, that one being adjustable, to that transistor, to its emitter, it creates the yellow line. And the yellow line is supposed to be 15 volts. So this is voltage regulation. And that's very important. Because if this section isn't working well, the orange, the 25 volts, and the 15 volts will not go to the rest of the circuit. And if you look at where this is going, because then I traced it, it sort of goes everywhere. It is the main feed line for the entire circuit, for all the boards. So we have to make sure that that is working correctly. So the best thing would be to disconnect this point here and that point there. And if we do that, we've isolated, I believe, yes, we would have isolated. This dotted line, dot dash line, is the outline of that board, of the supply and power amp board. So if I remove that there and there, we will have removed all the contacts, all the connection of the 25 volt line and the 15 volt line to the rest of the circuit. Now let me just see if there's another connection somewhere. This is ground. That's the input to the amplifier, input to the one side. That's the input to the other side. So that's just the input of the amplifier, the power amplifier. But I'm looking at power connections. Power connections, we've got this here would be the input from the transformer, which we should be able to see, but it's actually soldered. Yeah, that's soldered in. We need that there. Everything else seems to be soldered in. And I think there's just the one connector that we can remove. And I believe that's where our supply will be from. I have to check. There is a connector. That one, that one. It's actually got 4 lines, red, black, white, and brown. All right, I think it's time for a power up. I have the presumably damaged section of the radio removed. Make sure those connectors aren't touching anything. I've got Big Brother connected to the positive of the filter caps. We should get 55.6 or 56.5 volts with no input. And this one is connected to the emitter of that pass transistor, which should read 25 volts. Let's see what happens. I've got the dim bulb tester with maximum restriction, so only a 40 watt light bulb connected. So it's limiting quite a lot. And it's on limit. And it's on over there. Let's try it. Well, okay. 58 volts, that's not bad. That's actually close. But this one is way off, 7.8. That should be 25. So we've definitely got something wrong down there in the regulator circuit. So the next thing to do is to see whether we've got voltage coming into the regulator. The dial bulbs are actually all working. There are 3 of them. There's 2 on the behind the tuning dial, and there's 1 behind the little meter on the front here. So we've got a problem with that transistor or that circuit over there, which makes sense. This thing is drawing very little current. It's on 70 milliamps only, which is not bad. So we don't have major shorts, and leaky capacitors don't seem to be drawing too much current either. So the first thing to do is find out what's wrong with the voltage regulator circuit. Okay, first things first. Let's look at the fuse and see what we get there. So we're getting the full positive supply on there and on the other side of the fuse. Same. So the fuse is fine. Now we've got to look at that resistor. Voltage comes in, that's fine. What do we get on there? Yeah, resistor I believe is toast. 8.5 volts. What's that big resistor doing? 8 volts. 3.7, I think. Wait, hang on. Yeah, big resistor is also not seeing what it's supposed to see. So the collector of the Darlington is only getting 8 volts, and it should be getting a hell of a lot more. So we've got to change out that resistor. Start with that. But I'm curious to know why it burnt out. I wonder if this thing is bringing it down. This is that connector. I left it in, as you can see, and we've got a black, red and a black. These 2 are the AC going to the dial lamps. We saw on the schematic that it left that board. And these 2, that one there and that one there, one of them is 25 and the other one is 15. Now if I remove that, it means that nothing's being powered. Let me try that. Switch it off. Tuck it away. Now let's try again. Switch it on. Now what am I looking for? I'm looking for the input there. Let me make this guy faster. That's better. 59. The other side of that resistor. Oh no, still seeing that. The supposed 25 volts is that guy there, but I can't reach. It's getting 8, yeah. And the 15 is getting 8. Okay, the 25 is crucial. That's what we need to check first. I'll probably have to do away with these 2 caps because one of them could have caused the problem. Now, I won't even try trim the voltage there because the resistor is not letting anything through anyway. So we'll see what the resistance is on that thing. Switch this off. Now it's supposed to be 15 ohms. I think things have discharged already. 4 meg. Yeah, that would do it. Okay. Got to find a 15 ohm resistor. Okay, time for results or fireworks. What have I done? I've replaced this resistor. I've just left it there, and I've put in parallel with it 2 10 ohm resistors in series. So I've got 20 ohms. These resistors are 0.6 watts each, so we've effectively got 1.2 watts, and I've checked the service instructions. That resistor there is supposed to be a ½ watt, which seems a bit big for a ½ watt, but that's what it says in the schematic. Anyway, there's no current being drawn because that branch off for the supply has been removed. And I'm measuring with Big Brother the voltage at the emitter of that Darlington pair. So I should get 25 volts. Let's see what happens. Switch on the dim bulb tester and wait for it. Now. Well, that's not too shoddy, is it? Not shoddy at all. 28. Bloody hell. Might actually be working. I sound a bit surprised. I am. I'm going to try and adjust that voltage with that trimmer. Shift it left. It's dropping. That's 25 volts. That's very nice. Don't know what happens when we plug in the rest of the circuits, but that thing is working. And I don't know how hot this thing is getting either. But it's still drawing 70 milliamps, and it's pretty stable at just under 25 where I set it. Now I'd like to see what the 15 volts looks like. Let's try and get this out without shorting anything. Now the 15 volts we measure at the emitter of 803. So there's 803, there's the emitter. Bloody hell, nice. 14.8, that's close enough to 15 for me. It looks like that regulator is now working. I've got to do some work on this, and that's what I'm going to do now. I'm going to start reaping in rewards from finding something that's working. I'm going to actually replace that resistor. I'm not sure that I'm going to use that one. Again, I don't know whether I can get a 15 ohm resistor within any reasonable length of time because supplies are shut off. I might well leave those two in there for now and then later on replace it. But I'll put it in more neatly. I'm going to see how many of these capacitors I can actually change, the ones I've got, because it looks like our supplies are working. And right now, that's what I'm interested in, because what I want to do now is fix this regulator section and then plug the socket in here and see what happens when the rest of the circuits start drawing current. We might have a different scenario because something burnt that guy out. Don't know what it is. Usually it's excess current. Usually it's a short somewhere. Alright, I've swapped out two capacitors and not one but two resistors. These two went out. That was Mr. Fried over there. And this guy is resistor 804, which was supposed to be 150 ohms, and it's reading like 700k. Rather 700 ohms. So this one is gone as well. And I've replaced that. That's supposed to be a 1 watt. I've replaced it with a 150 ohm 2 watt resistor. This guy I replaced with a combination of two 10 ohms in series, giving 20, and I put a 68 ohm in parallel, which comes to just under 15 ohms. And it's quite accessible, so when I get my component order in, that's quite easy to change over. So let's try again. Big guy is measuring 25 volts, should be. Small guy is measuring 15. Let's have a look. Bloody nice. A little bit high, but don't forget there's no current being drawn at all. I have the that connector disconnected, so this is really under no load. I expect that when I do connect it, we should get a small drop. In fact, that's what I'm going to do now. I'll switch it off. Let them discharge. They take a while because, as I said, there's hardly any load. And plug this guy in. It's now plugged in, and I hope we don't have sparks. Let's have a look. That's pretty good. There's no shorts. There are no shorts. That guy's still 1 volt over. That one's pretty much spot on. What happens if I select something? If I select FM. It's pretty constant. Bit high. I've got a feeling that's got to do with that diode bridge or that diode configuration they've got there, which creates a reference. But that's not going to do any damage for anything that's expecting 15 volts. So for now, that's going to stay in. And I'm quite happy. Adjust that just a little bit. I'd rather have it a bit lower than a bit higher. Okay, that's it. Our voltage regulator is fine. The supply voltage seems to be there, as we measured earlier. And let me show you what's been done on the schematic. So, I have replaced that resistor there. And I've replaced that resistor there. And I've replaced that capacitor and also that capacitor, and everything else seems to be working okay. So we can actually say that this section seems to look good, and I'm just having a quick look to see if there's anything else that I should replace here. I think that excessive voltage there, that is 16 volts. I wanted 15. But what I've got here is 12 plus 1, 2, 3, 4. Now 4 times 0.6, say, is 2.4. 2.4, 14.4. It should be 15 volts over here. That should be 15. Never mind, I think that's good enough. They do mention that all voltages are measured reference to ground, and it's with a certain voltmeter that would probably be lower impedance than these digital meters, so they would show a lower value, and also that your voltages could be 15% out. That's quite an error there, Lars, so I think we're good. And actually, I think we're good for today. I'm going to do some cleaning on the board. I'm going to make a list of the components I need. I need quite a few caps, and try and get them. I won't wait for the caps before I continue, because I want to basically get to the point where I can test to see if all the audio section is working, and then the caps hopefully will just be improvements. So the idea is get certain things scheduled here so I don't suffer too much from the fact that I've got to wait for a while to get components. When I say while, I'm not sure how long they're taking to deliver, but I'll have to just order it and see. Right, guys, thanks for watching. By the way, I want to thank you all for a lot of offers of support and help, especially with translations made in the comments of the first video in this series. It seems I'm not the only one who's a Braun fanboy, and I may well need your help on some of the German on the service manual, and if I do, I'll ask. So thank you once again. Thanks for watching. And if you like it, please click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Stay healthy, and thanks for watching. Bye for now.